Hi, guys, it's Mrs. Seitz. To kind of follow up on what you guys learned yesterday about conditional statements, I'm going to throw on some of the important postulates that we've actually been learning throughout geometry, and we're going to use those as conditional statements as well and apply some truth values with those. So, in chapter one, we actually studied some four postulates without really necessarily stating a couple of them so much. We didn't really talk about the ruler postulate, but basically, what the ruler postulate says is if you measure any 2 points, there exists a measure between the two of them. We did talk about the segment addition postulate. We did kind of talk about the protractor postulate, which basically says if you measure any type of angle using a protractor, a measure exists between the angle. And when we did talk about the angle addition postulate, which basically says, remember, if you split up the angle into little tiny parts, if you add up all the little tiny parts, it will give you the big angle. But remember, postulates are assumed to be true, and they form the foundation on which other statements called theorems are built. And that's what we're going to be looking for in the future. So we have to make all these little assumptions in geometry, and we are assuming that they are true so that we can build that solid foundation to get where do we want to be. So if we read through these postulates, postulate 5 says through any 2 points there exists exactly one line. Postulate 6 says a line contains at least 2 points. Postulate 7 says if there are two lines that intersect, then their intersection is exactly at one point. Postulate 8 says through any three non-collinear points, there exists exactly one plane. Postulate 9 states a plane contains at least three non-collinear points. Postulate 10 states if 2 points lie in a plane, then the line contains the line in the plane. And postulate 11 states if two planes intersect, then their intersection is a line. And we did touch briefly upon those as well in chapter one. But if you guys go into your classwork section and you take a look at the point, line, and plane postulates, I actually included a Google slide for you that actually gives you a visual representation of each one of these postulates as well, because I like to see things visually for myself just to make sure that I know what's going on. And again, remember I said a postulate is a statement that is accepted as true without proof. Okay, this is that 2 point postulate. So that's the first one, that postulate 5. Through any 2 points, there exists exactly one line. So there's a nice visual representation of that. The line point postulate, a line contains at least 2 points. Nice visual representation. If two lines intersect, then their intersection exists in exactly one point. The 3 point postulate, through any three non-collinear points, there exists exactly one plane. I just think this really is helpful for you guys to visually see what's going on. Plane point postulate, a plane contains at least three non-collinear points. Plane line postulate, if 2 points lie in a plane, then the line containing them lies in the plane. Plane intersection postulate, if two planes intersect, then their intersection is a line. Remember, I showed you guys that with note cards. Okay, so those are all those postulates that I would be talking about, right? Okay, but I want you to realize that they exist visually as well, and we've talked about most of them. We're going to apply those now with conditional statements. So rewrite postulate 5 in an if then form. So postulate 5 is through any 2 points, there exists exactly one line. So I want you to pause our video and I want you to see if you can come up with an if then statement for postulate 5. Then I'd like you to also write an inverse, a converse, and a contrapositive. So remember, an inverse is taking our hypothesis and conclusion that you're coming up with and you're negating it. A converse, remember, takes your hypothesis and conclusion and flip flops it around. And a contrapositive flip flops it and negates it. So I want you to pause your video and see if you are able to come up with that. All right, I hope you were able to pause your video and see if you are correct. So the right answer for the first one is if 2 points are distinct, then there exists exactly one line that passes through them. Here would be the inverse. So remember the negation. If 2 points are not distinct, then there is not true that there is exactly one line that passes through them. And again, if you have something that is relatively close to this, then that is perfectly fine. The converse of the flip-flop is exactly one line passes through 2 points, then the 2 points are distinct. And the contrapositive, remember, flip-flops and negates. If it is not true that exactly one line passes through 2 points, then the 2 points are not distinct. So I hope you got those right. And the last thing for today, decide whether the statement is true or false. If it is false, then give a counterexample. So using those points, line, and plane postulates, a line can be in more than one plane. 4 non-collinear points are always coplanar. And for C, 2 non-intersecting lines can be non-coplanar. So again, pause your video and I want you to really think about these statements, thinking about the point, line, and plane postulates. So line can be in more than one plane. 4 non-collinear points will always be coplanar. So non-collinear means, remember, you don't have a straight line. Coplanar means that you are existing on the same plane. For part C is 2 non-intersecting lines are non-coplanar. So we have 2 lines that are not touching they are not being in the same plane. So think about those as true or false. So pause your video and see if you are able to come up with the true answers for these. All right, I hope you were able to do this correctly. Let's see if you got them right. All right, so for part A, a line can be in more than one plane. All right, so in this diagram that I have here, line K is in plane S and line K is in plane T. So it is true that a line can be in more than one plane. So I hope you guys came up with true on that one. True for now letter A. All right, so for part B, 4 non-collinear points are always coplanar. It looks like this one is false. Consider the points A, B, C, and D at the right. The points A, B, and C lie in this plane, but there is no plane that contains all 4 of them. Look at this one. So it is shown as a counterexample. So this last point out here, it's definitely showing you that it's not collinear and it's not on that plane. So this would be giving you the counterexample. And for part C, 2 non-intersecting lines can be non-coplanar. So this one was true. In this diagram at the right, line M, so right here, and line N are non-intersecting, right? Line M's up top, line N is on the bottom, and they are non-coplanar, right? So they're not within the same plane. So because of that, it is true that you can have a non-intersecting and a non-coplanar. All right, so hopefully you did all right with that. And again, today's lesson was just short and quick, and it was just a quick little application of how some of the things that we had been working with in chapter 1, some of those ideas are actually tying into our logic unit with our conditional statements.